Okay, so this is a video on how you would interest continuously versus in placing interest compoundedly. So as you can see here, there will be two formulas that we will be using. So with the compound interest, it's about your final amount's gonna be principal amount, which is the initial amount that you're taking, times by 1 plus r over n to the exponent of n times t. So here what we actually have is that P is the initial amount that you have. It could be the amount given in the problem, that's your initial value that you're going to take. So this will be denoted as the initial amount, and then your R is your rate, so that could be given as 5% or 7%, and then if it's 5% you would write it as 0.05. And then n is the number of times you're compounding it. That will be listed within the problem. For instance, it may say semi-annually, which means you will be placing in 2 in for n, and based on that you're going to place in 2 on the exponent as well, and multiply that by the number of years you're compounding the interest for. So let's take an example. For instance, say that we have R is 2% and T is 10 years. And we're given that the initial amount is $2,500. So given these values, all we're really doing is substituting these values in the formula. So if you know the formula, it shouldn't be that difficult. So you would just do A is equal to 2,500 1 plus, so as you can see, this is 2%, so that means that we're going to place this as 0.02 divided by, well, so the n depends on like what it says in the problem, so let's assume that it says it's being compounded quarterly. So this means that we're going to divide it by 4, because when you're talking about quarterly, that means that there are 4 time periods that you're compounding your interest within that one time year frame. And then, as we know, it's 10 years, so we're just taking this value, so it would be 4 times 10. And now you're really doing is you're just putting these values within the calculator. So you could just place in 2,500, and then you have 1 plus 0.02 divided by 4, where we're going to raise this to the power of 4 times 10. And so we should be getting the value of $3,051.98 or 99 cents after rounding the answer. So now when we come to, let's just use the same hypothetical example, but for this one the formula will be A is equal to P E R T. So in this case the P is the initial amount again, so you would have 2,500 here. E is your constant. On the calculator it's this one, so second this, so that will give you E. And then your RT is R is obviously your rate, and T is the time. So in this case your rate's 0.02, and then your time is 10 years. And again, all we're really doing is just substituting these values in the calculator, so it would be 2,500, and you have the power of E to the 0.02 times 10. So you should be getting $3,053.50. So that's your final amount that you get. And so if you just compare these two values, you see a pattern that obviously these are pretty close, but if you were to calculate your interest by compounding it continuously, it's going to be slightly higher than the amount that you got when you compounded it monthly, or in this case quarterly. So compounding it continuously will give you a slightly higher value. So this is the video on finding, basically determining the difference between compounding interest